Alrighty, so we are doing dilations practice 2 today, and I want to review dilations, and I'm also then going to quickly review translations and reflections because that is also on here. Dilations, this is your overview card. You should have gotten it. It should be in your reference part of your binder. Please get it out now. If I see you with this not in front of you while these notes are going on, I'm going to come over and get a little upset with you. So please get it out, okay? Overview. A general rule for dilations. When you are dilating something, you are either making it larger, which is called an enlargement, or you're making it smaller, which is called what? Hopefully you remember, a reduction. So a general rule is written when you take the scale factor times your x and the scale factor times your y to find your new image or your new point, either one, or new side length, okay? Images are similar. They are the same shape but not the same size. Angle measures are always congruent. So in other words, a small square has 4 90-degree angles. Well, if you draw a large square, you still have 4 90-degree angles. So it doesn't matter about size. The angles are what maintains the shape. Okay? So we said an enlargement is when you are using a scale factor greater than 1. A reduction is a scale factor less than 1. If you have the same size or the two figures are going to be equal, that means you used a scale factor of 1. Now, I'm telling you right now to do this packet, everything you need is right here, but you have to be paying attention and know how to come back to it, okay? To find a new point, all you do is multiply the old x value and the old y value by your scale factor, whatever your scale factor is. So, for example, if I have an x, I multiply it times the scale factor, I get my x prime. Remember that when you have this little sign here, that means it's the new x, or the new image, all right? So, to get your new y, you would take y times the scale factor equals your y prime, okay? That's the new. To find a new side length, multiply your old side length by your scale factor. So if my side length was 5, my scale factor was 2, I would take 5 times 2 and my new side length would be 10. Okay? To find the scale factor, okay, there are 2 ways. All right? Ultimately, you use the same formula, all right, which is just say no, all right? We use just say no, like you say, just say no to drugs, because you're putting your new and dividing it by your old, all right? So new over old, so just say N-O, no, okay? And we abbreviate that by doing this sometimes, and that's where we get the no, all right? You can either use corresponding, which are the same place, the same side length, the same point on 2 different figures, okay? Corresponding points, all right? So you would use your new x over your old x and then simplify that, or your new y over your old y and simplify that, okay? Using corresponding side lengths, you scale factor equals your new over your old. So you take your new side length and your old. And remember, I had you put an N in your new figure and an O in your old figure. So old image or original image, so that you would be able to identify those easily. If you do that every time, you'll be successful. All right, the last thing I want to do, and I'm going to do a quick review on back here. All right, we have translations. That is another transformation, okay? Translations, remember, always look like this. General rule is x, y, and you have either x plus something or minus something, and then you have y plus a value or minus a value. And what that is when you have x plus, it means something, you're going right. When it's x minus something, you're going left, okay? When you have y plus something, you're going up, because the y-axis, you can only go up and down. And if you have y minus something, you are going down. So that is pretty simple. A translation is just sliding something. They always maintain congruency. Translations, it's always the same size, always the same shape. It's even what we call, man, my brain is not engaged. It's the first day back and I'm trying to make this video. Visually, it looks the same. So visual orientation looks the same. In other words, the square will look like a square. The star, the point of F, will be looking in the same spot as the point of F in your new image. Another transformation that we have is called a reflection. Okay? And a reflection is movement where you flip something. So reflection is a flip or a mirror image. When you look in the mirror, you know, your left always looks like it's on the right, and your right always looks like it's on the left. It's a flip. And you can only, a general rule, so for every XY value, all right, you're either going to change the sign of X, leave Y alone, and that is a reflection over the what? Y-axis. So when you flip over the Y-axis, you change the sign of X. Remember, that doesn't mean make it a negative X. It means change the sign. This is when, you know, transformations, they make it crazy, and you have to realize that. So reflection X, Y, another general rule that you can have, and you can only have two, so it makes it pretty easy, is leave the X alone, change the sign of Y. And that is a reflection over the X axis. And I'm not going to go over rotations today. That would be the last type of transformation you have. Coach Cloudy and I will go over those later. So just so you know, we have translations, reflections, and this packet is a lot about dilations. As you open this packet, you should be able to go here, and as you read this, you should be able to use your card to help you. The first three are pretty much everything up in here. Okay, then you get here and it says these two figures on a coordinate plane, what is the scale factor that is applied? Well, remember I said do old and new, and did it get bigger or did it get smaller? Use common sense. It got what? Smaller. Well, if it gets smaller, it's called a reduction. That means your scale factor has to be less than 1. So which one of these answer choices is a scale factor that is less than 1? That's all you have to do, okay? When it comes over here to number 5, it says triangle PQR has coordinates of P 2, 4, Q negative 2, 4, R 0, negative 6. Write the coordinates of the vertices of the image of the triangle after a dilation of 1.5. So all you have to do is, how do you find scale factor from points? You want new points. It says you have a scale factor of 1.5. So to find a new point, you're going to take your x value, multiply it times your scale factor, you find your x prime. So I would just do 2 times 1.5 in my calculator. Some of you know that, some of you don't. Some of you need to grab that handy dandy calculator out and put 2 times 1.5, and I get 3. So my P prime, the x value, would be 3. And my y value, you do the same thing. You do 4 times 1.5, and I get 6. So there's my P prime. And that's all there is to this. If you have any questions at all, please ask us. We'll be more than happy to help you. Make sure you read your questions so that you know what they're asking you to do, and have a great day.